All right, so now for example number 3, we're going to look at bacteria growth. Speaking of the ACT and SAT, if I say example number 3, bacteria growth, just from the things that I've written on the board right now, what do you know about this function? There's a clue in the words that I've written down. It's increasing. That means that the rate would be what? Positive or negative?
Positive.
Positive. Yeah. So this tells us that it's increasing and that the rate is positive. So before we even get started, that's what it tells us. Well, it says that we, suppose we have a culture of 100 bacteria. So we start with 100 bacteria. Okay, and we put it in a petri dish, and then it says that it doubles every hour. And they want us to predict when we have 350,000 bacteria. Okay? So just let me say that again. We're going to start with exactly 100 bacteria in a petri dish. And in an hour from now, I'll have 200. 2 hours from now, I'll have 400. And so let's write that down, what that looks like. I start off with 100. How many hours have passed? 0. After 1 hour, it doubles. I'll have 200. After 2 hours, I'll have 400. After 3 hours, I'll have how many? 800. It doubles every hour, right? After 4 hours, I'll have 1,600, right? And after 5 hours, I'll have 3,200. Now, I could keep writing this out until this bottom number becomes 350,000. That might take a while, right? Or I could write a function. What clues have I written down to help me with this? So the function, if it's an exponential growth, let me zoom out a little bit. If this is an exponential growth, that means that I could write a function that looks like this. Or I might even be able to write it something like this. Where there's a base. Well, what do we know so far? Start with 100. So what's that tell us with regards to the equation? Well, yeah, you could add 100. But how do I get from 200 to 400? Do I add 100? What does doubling mean? What are we doing to get from 100 to 200 to 400 to 800? Yeah, so I'm multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2 to get me from one number to the next, right? What would we call that? A number that you multiply by? Well, I need to know two things to write this equation. I need to know the initial condition, and I need to know the base, what I'm multiplying by. So, help me finish this equation. P naught represents the initial condition, which is 100. Now, what is the base? 2. Now, would that work? Let's see. If I take this equation and I put it on the calculator, and I say 100 times 2 raised to the, and I got to put x instead of t. And then I look at the table of values, I get, well, at 0 I get 100, at when x equals 2 I get 400, 800, 1600, right? If I keep going I get 3200, 6400. Now I could scroll until I get to 350,000, but how do I know exactly? So it looks like it occurs, I gotta go back up. After 11 hours I'll have 248,000, yeah? Or 204,000, I'm sorry, 800. And then at 12 hours I have 400,000. So it looks like between 11 and 12 hours is what it's gonna take. But I wanna be mathematically precise. So how do I solve that? Well, I've already entered in the graph, and so this is the exponential function, and I just got to figure out what value for x will give me a y value of 350,000. So one way that we could solve an equation is I could take one side, I could say 350,000, right, is equal to 100 times 2t. Now, how could I solve that using my graphing calculator rather quickly? Yes?
Just hit value and then type in 350,000.
Hit what? I didn't hear what you said. Could you repeat that?
I think you hit value.
Value would be you would plug in the x, and we don't know what that is. Right? So she's saying maybe it's, if you come in here and you hit calculate, if you plug in value, but see if I plug in like 2, that just tells me what the function is evaluated at 2. Now, we've done this before. You guys just don't remember. It's the first day back from our extended break. Right? Haven't we done this before where we take one side of the equation, right? We've taken one side of the equation and we plug that in as a separate equation on our calculator, and then the other side as a separate function. So if I did something like this, 350,000, and then what we need to do is we need to look for where the two intersect. The problem is that when I do that, I don't see the other function as a graph. I don't see the line. How come? It's too big of a number. Right now, I am not, my y values aren't up to, what number do my y values need to be at? Look at the equations. What does y equals 350,000 look like graphically? It's a straight line at what y value? 350,000. So what I really need to do is I really need to come into my window and I need to change my y values to what? Yeah, about 350,000. So I'm going to say 349,999 for my minimum value, and then I'm going to say 350,001. Now when I hit graph, it's going to look a little weird, but right through the middle there should be a straight line. It'll take a second, I think, for it to calculate, because those are some big numbers, right? So there's my line of 350,000, but now my x value is different. So I'm going to need to change my x value because I don't see the other graph. So I'm going to say 0 to 10 is probably not big enough. So let's change that to 20. Now let's hit graph. So there's my first function, and there's my second function. So now what do I need to do to find the solution to this right here, because that's what we're trying to do. We're trying to find the solution to this. We're trying to figure out what value for t, or x, as we say on our calculator, gives us 350,000. How do I figure that out? Find the intersect. So now the calculator will do this for me if I hit second trace and I go to the calculate menu and I hit intersect. Now here's the problem. It says that I need to do the intersection at a point, so I've got to find the intersection at this point. So I'm going to come in here I think I clicked the wrong thing though. Yeah. If I hit second calc, I'm going to come down to intersect, which is 5. And I need the first curve. And it's going to be really hard to get it to show on the screen. And then it says the second curve. And I want to get that as close as I can. And it says the intersection is 11.77. That's the x value, right? So what that's saying is that if I plug in 11.77, that should work. How could I verify that?
Put it in for t.
Yeah, plug it in for t. So I'm just going to quickly, real quick, I'm going to come in here and I'm going to say 100 times 2 raised to the 11.77. Now, it's not going to be exact because Mr. Adams is rounding, right? But is that close enough to make us feel good? Yeah. So what does that mean, though? If you had to explain, we just did this long math problem. Let's say that your mom or dad walked in the room. They said, "What? That looks complicated. What did you guys just do?" What would you tell them? We calculated, finish the sentence.
How much bacteria, or how long it would take to get 350,000.
Yeah, we predicted how much time it would take to get 350 bacteria if we started with 100 in a petri dish. Does that make sense? Are there any questions?